There is a place on Earth where you can literally watch a super volcano breathing, where the ground rises and falls like a chest filling with air, where the sea itself is beginning to boil, not from heat alone, but from gases rising from deep underground. This place is Campi Flegrei, the burning fields, and it sits directly beneath one of the most crowded cities in Europe. 3 million people live above a volcano that's slowly waking up. I want to explain what we're observing there, because what's happening is a masterclass in how planetary systems communicate danger. If you know how to listen, fishermen noticed it first. Bubbles breaking through the calm Mediterranean surface. Then came a low rumble echoing from below the sea. What looked peaceful on the outside was hiding something enormous. When you see something like that, when you observe the surface of the ocean shimmering with heat and gases, you're not looking at a curiosity. You're looking at a geological alarm. Scientists believe that the sea near Naples is literally starting to boil, not from a heat source at the surface, from gases rising from deep underground. Carbon dioxide, sulfur dioxide, helium. These are volatiles escaping from a magma chamber that's pressurizing below. The water is reaching temperatures several degrees higher than normal. Hundreds of small vents releasing energy continuously. The surface looks like it's simmering. This is Campi Flegrei, one of the most dangerous super volcano systems on Earth. A caldera, a volcanic depression created by ancient collapse that spans 13 kilometers across, and it sits directly next to Naples, home to over 3 million people. A city built on top of a system that's entering an active phase. For decades, scientists observed a pattern here. The ground would rise, then it would sink, like breathing. This phenomenon is called bradyism, slow uplift and subsidence caused by magma or gases shifting below the surface. In the town of Pozzuoli, the land has lifted by more than 4 meters since the 1,950 seconds. Streets have cracked. Ancient Roman buildings have tilted. Parts of the coast that were once underwater now sit above the sea. The archaeological evidence is visible. The geological record is written in stone. But what's happening now feels different. Recent satellite data shows that the seafloor near Naples is rising again, faster than before. And the pattern of what's rising is revealing something profound. Deep beneath Campi Flegrei lies a massive magma chamber, wide enough to stretch under the Bay of Naples itself. For years, scientists thought this chamber was mostly solidified, a cold storage tank of old magma that had cooled over time. But new measurements are telling a different story. Using advanced satellite radar and GPS instruments, researchers have discovered that molten magma is slowly pushing upward, melting rock as it rises. The magma hasn't reached the surface yet, but pressure is building. Think about this physically. You have molten rock rising through solid rock. The friction between them generates heat. The pressure builds incrementally. The rock above begins to crack. Small fractures at first, then larger ones. The system is stressing itself toward failure. And we can measure this stress. We can see it in the data. Over the past weeks, there have been thousands of small earthquakes in the Campi Flegrei region, sometimes dozens in a single day. These are not random tremors. These are stress fractures forming as the rock responds to increasing pressure from below. In the past, these earthquake swarms would stop after a few weeks. The system would settle, pressure would dissipate, stability would return. This time, the swarms are continuing, week after week. The earthquakes are also becoming shallower, getting closer to the surface. That's significant. When earthquakes migrate upward, it indicates that pressure is rising through progressively shallower parts of the system. Stress is redistributing toward the surface. One volcanologist described the current situation as a ticking clock, and I understand why. Because all the classical warning signs that appear before a major volcanic event are appearing simultaneously, not one or two, all of them at once. Ground uplift at record speeds. The land is rising faster than at any point in recent history. Gas emissions are elevated. High levels of carbon dioxide, helium, and sulfur dioxide. The gases are escaping more abundantly than before. Seismic swarms are intensifying. The earthquakes are increasing in frequency and migrating upward. Any one of these on its own might not signal imminent disaster. But together they paint a picture of a system entering an active phase, a system where pressure is building faster than the system can accommodate. Some experts now warn that we're approaching a critical point, a moment where the rock above the magma chamber becomes so fractured, so weakened, that it can no longer contain the pressure. At that threshold, gas and molten material could burst through, not a gradual opening, an explosive rupture. Others describe a different scenario. They warn that even without a full eruption, the release of underground pressure could cause massive steam explosions under the sea. Seawater flashing to steam instantaneously. Boiling water and ash hurled into the sky. A hydrothermal blast powerful enough to devastate the surrounding coast. Waves generated not by earthquakes, but by the violent release of subsurface pressure. The area scientists focus on most intensely lies between Pozzuoli and the Bay of Naples, a section of the seafloor that's become increasingly unstable. Drones and thermal cameras show water temperatures rising by several degrees, plumes of gas rising continuously, hundreds of small vents releasing energy from below. The water literally looks like it's simmering. And this isn't unprecedented. The last time this happened was before 1538, before a major explosion that created an entirely new volcano, Monte Nuovo. It rose from the ground in just a few days. An entirely new mountain where there had been farmland. That eruption was small compared to what Campi Flegrei could produce. But it completely reshaped the coastline. Towns disappeared. New hills formed. The bay itself changed shape. Could it happen again? Scientists don't know exactly when or how the next major event might occur. But they agree on one fundamental thing. The system is far from quiet. It's transitioning toward activity. What troubles them most is that Campi Flegrei has become weaker over time. With every episode of uplift, and there have been many, the rock above the magma chamber cracks a little more. The system has been stressed repeatedly. The rock is accumulating damage. That means it could take less pressure now to break through than would have been required decades ago. The barrier between surface and magma is thinner, more fractured, more permeable. If magma reaches the surface under the sea, the consequences would be catastrophic. Seawater would flash to steam instantly, not gradually, instantly. The pressure from that expansion would create violent explosions. Tsunami waves would radiate outward. Ash would rise into the atmosphere. The coast of southern Italy would be transformed in minutes. I need to emphasize this point. Unlike earthquakes, which produce sudden violent shaking but are over in seconds, a volcanic event could unfold over hours or days. But the initial explosive phase, the moment magma meets seawater, that happens faster than any warning system can respond. The Italian Civil Protection Department has already raised the alert level for the region. Monitoring stations have been increased. Evacuation routes are being reviewed. Siren systems are being tested. Authorities insist this is precautionary, but locals remember the 1,980 seconds. They remember when tens of thousands were evacuated after similar warning signs. They remember the uncertainty. the fear, the disruption. They're not reassured by promises of monitoring. They're worried about what comes next. There's also something else that concerns scientists. Campi Flegrei isn't isolated. It's part of a much larger volcanic network that includes Mount Vesuvius, the same volcano that buried Pompeii in AD 79. Some scientists believe that deep magma channels may link the two systems, that pressures in one could affect the other. If one system destabilizes, it could potentially trigger cascading effects in the other. The idea of a chain reaction, where one volcano's movement triggers another, is terrifying, but it's not impossible. It's rooted in the physics of interconnected systems, pressure flowing through pathways, stress redistributing, one system's change becoming another system's trigger. This is why the current unrest in Campi Flegrei is being watched worldwide. Not because it's necessarily going to erupt tomorrow, but because if it does, the consequences extend far beyond Naples. They could affect the entire Mediterranean region, and they could potentially trigger responses in connected volcanic systems. What makes this situation so challenging is the inherent unpredictability. We understand the physics. We can monitor the signals. We can see the warning signs. But we cannot predict exactly when the transition will occur from current activity to major eruption. Will it happen gradually? Will there be more time to prepare? Or will the system accelerate rapidly, crossing from manageable unrest to crisis in days? Every bubble that breaks the surface of that sea is a message from below. Something is moving, something is pressurizing, something is working toward release. The boiling water is literally the volcanic system communicating, if we know how to interpret the signals. The situation around Naples reminds us of something fundamental. The same geological forces that built Italy's beautiful coastline are also capable of destroying it. The volcanic activity that created the fertile soils that support Mediterranean civilization is the same volcanic activity that poses the greatest threat to that civilization. Campi Flegrei is one of the few places on Earth where scientists can literally watch a supervolcano breathing, watch it stretching, watch it cracking, watch it changing shape in real time. We can deploy instruments, we can collect data, we can model scenarios, but ultimately the volcano operates on its own schedule, according to its own physics. Following the deep processes that have been at work beneath southern Italy for hundreds of thousands of years, the boiling sea is not a curiosity. It's not a tourist attraction. It's a warning. The system is active. Pressure is building. And the ground beneath Naples will never truly rest. Not today, not tomorrow. The volcano is breathing. And each breath brings it one moment closer to the next major release. What we can learn from this is that even in the most studied, most monitored volcanic systems on Earth, uncertainty remains. Science gives us tools. Understanding gives us context. But prediction remains elusive. The future of Campi Flegrei belongs to the volcano. And we can only watch, measure, monitor, and prepare for whatever comes next.